The slope of a line is measured by the ratio of how the line rises to how the line runs. Now, when we talk about rise and run, those are two words that are used to describe movements on the y-axis and the x-axis. The y-axis is this vertical line. So on this vertical line, we can either go up or we can go down. So that is why we talk about a rise. So the slope is a ratio that measures how much the line is rising to how much the line is running. Now, running happens on the x-axis. You can run on this level ground, this road that looks like this horizontal road. That is where you can run. So you can run to the right or you can run to the left. So to find the slope of a line, to determine how much the line is rising to how much it is running, you first want to pick 2 points on the line. In this case, I'm going to pick these 2 points. I could pick a point here and a point here too. Now let us use these 2 points to travel from the first point to the second point without using this line. Then I'll have to travel horizontally and then vertically. I indicate my direction of travel with an arrow. I am traveling horizontally 3 units, so I consider that since this coordinate grid does not have numbers, I consider that 1 square is 1 unit. So positive 3 because I'm traveling 3 units to the right. Now from here, I'm going up to get to this point. I will consider that as positive 2 because I'm going up. If I was going down, it would be negative 2. Now, I could make another triangle. It doesn't have to be these 2 points. I could pick, said, I can get a second triangle. From this point, I can travel horizontally until I get to the turn where I go up vertically to hit the second point. So I have traveled vertically 1, 2, 3, 4, 5, 6 units. That is positive 6 because I'm going up. And here will be positive 1, 2, 3, 4, 5, 6, 7, 8, 9. Positive 9 because I'm traveling to the right. Now the slope is the rise divided by the run. So these vertical lines here represent the rise. That is how much I traveled up. The run is this horizontal travel. So this is the run. So to get the slope, I will simply get the rise divided by the corresponding run. So in this first triangle, my rise is 2 divided by a run of 3, and that is the slope. The slope simply tells me that the line is rising 2 units for every run of 3 units on the x-axis. So if I start here and I run 3 and I rise 2, I get here. Run 3 and I rise 2, I get here. Run 3, I rise 2, I get here. I run 3, I rise 2, I get to another point here. So that is how I can get many points on the line. Also, I could calculate the slope using this bigger triangle. Using the bigger triangle, the slope will be a rise of 6 divided by a run of 9. You may think that the slopes are different, but the slope along any straight line is the same number. This is an equivalent fraction of 2/3 because we can simplify this by dividing here by 3 and dividing here by 3, and that will bring us to the same slope of 2/3. So the slope of this line is 2/3. That means the line has a rise of 2 and a run of 3. Now, this graph shows a real-world scenario where we have cost of tickets versus the number of people who bought the ticket. So from this line, I can see here that 6 people paid $15 for a ticket. From this graph, I can read a lot of information. However, finding the cost per ticket can help me to project how much will be paid by any number of people. So that cost per ticket is also called the slope of this line. So the cost per ticket is the unit rate of this graph, which is also called the slope. So remember the strategy for finding slope. We can use that strategy to find the cost for one ticket. We see on the x-axis here, this is the x-axis that has been labeled as number of people. Remember, that will still be the x-axis. Ticket cost is the y-axis. So remember that slope is the rise divided by the run. Okay, so consider this point. Consider this point and this point. 2 squares is 6 units, then that means 1 square is 3 units. So we have 3 here, 9, 12, 15, that will be 18, 21, and 24, and it keeps going. So from 6 to 12, that will be the run. So the run will be 12 minus 6, which is 6 units. The rise goes from 15. We can read this here. We can read the start of the rise from the y-axis here. This is 15. It rises all the way to 30. So we can see that the y-axis is calibrated in 5. So 1 square is 5 units. This will be 5. This will be 10. This is 15. This will be 20. This is 25. Then this will be 30 and 35. So we have a rise from 15 to 30. So our rise will be 30 minus 15, which is 15. So this gives us a slope of, so our slope here will be the rise of 15 divided by a run of 6. Okay, notice that this slope also represents this point where 6 tickets cost $15, which is the rate. Okay, but is that the unit rate? No, the unit rate will be this equivalent fraction in simplest form. That means the cost per ticket. We want to find the cost for one ticket. So we can simplify this fraction of the slope being 15 divided by 6. We can divide here by 3 and divide here by 3. And that can simplify to a slope of 5 over 2. So 5 over 2 is the same as 2.5, which is also 2.5. Okay, so in this scenario, this numerator is money in dollars. So this is $15 out for 6 people. So if we divide, now we have $2.5 per person. So the unit rate, which is also the same as the slope, is $2.5 per person. So $2.5 per ticket. So one ticket costs $2.5. And that is the relationship between unit rate and slope. The slope is the same as the unit rate, which is the cost for one ticket. Another word for a slope is a slant. Does a horizontal line have a slope? We'll find out. So does this line have a rise? No. So any horizontal line, so this line is horizontal, that means the slope is 0. So A horizontal line has a slope of 0. We want to find the slope of this vertical line. This vertical line does not have a run. That means the run is 0. Remember, slope is rise over run. So this line has an infinite rise. So let's say the rise is just 10. But then the run is 0. So division by 0 is not possible. So the slope of a vertical line is undefined. A vertical line does not have a slope. It is undefined.